Hello everyone, so today we're going to look at this calculus 2 question, sigma 1 to infinity n squared of sine of 1 over n, does that converge or diverge? Alright, so we're going to be using the divergence test today, and it says given n equals 1 to infinity a sub n, if the limit as n goes to infinity of a sub n does not equal 0, then the series diverges. A very useful test because you take a limit of your sequence, and if that limit does not equal 0, then you're done. You don't have to really do anything else with this. If you look at other tests involved of finding whether a series converges or diverges, they're a little bit more involved and require more steps. But here we just have to take a look at limits, and we have tools for limits that we've learned before, which we'll use today. So let's go ahead and apply the divergence test here. So I'm going to take the limit as n goes to infinity of n squared sine of 1 over n. Now, when n goes to infinity, n squared goes to infinity. The sine of the quantity 1 over n, that goes to 0 because 1 over n goes to 0 on the inside, and the sine of 0 is 0. Okay, so it's got the form of infinity times 0, which is an indeterminate form. And an indeterminate form is a form which you don't know what the limit equals, and you have to do a little bit more work, some algebra, some calculus. In this case, we're going to do a little bit of both here, algebra and calculus. Now, the work that usually, one of the tools that usually you can use here is to use L'Hopital's rule. The issue is I can't use L'Hopital's rule right now. L'Hopital's rule, if you recall, only works when you have you have 0 over 0 or infinity over infinity as your forms when you're taking the limit. So we don't have that. However, we can take care of that right now. I'm going to rewrite that expression, that sequence, n squared sine of 1 over n, as sine of 1 over n divided by 1 over n squared, or the limit as n goes to infinity of sine of 1 over n divided by n to the minus 2. These are equivalent to each other, and they're both equal to n squared sine of 1 over n. Okay. Now, why am I doing that? Because when you have it in this form of sine of 1 over n over 1 over n squared, when you go to infinity, both the numerator and denominator go to 0. Okay? And then I can use L'Hopital's rule for that. All right, so the trick, essentially, when you have infinity times 0 is you keep one of the forms on top, and then you divide the other by 1 and put it under that function you kept on top here, or the sequence, excuse me. Now, L'Hopital's rule works with functions only. So what we often do for that is we rewrite the sequence as a function. Essentially, we kind of replace the n with x. And let's apply L'Hopital's rule. So we're going to take the derivatives of the numerator and denominator, and I'm not going to go over L'Hopital's rule here, what it says exactly, so I'll let you look that up. And we're going to take now derivatives of numerator and denominator. So the numerator is going to be cosine of 1 over x times minus 1 over x squared. So I use the chain rule on that. And then for the denominator, it's minus 2 over x cubed. So I would go ahead and maybe pause this video to see why that is. And I'm going to simplify this a bit. This becomes cosine of 1 over x times minus 1 over x squared times x cubed over minus 2. So using some algebra, some stuff flips, and some x's cancel, and you get x cosine of 1 over x all over times a half. And as we go to infinity, cosine of 1 over x goes to 1, x goes to infinity. So essentially what you have is something going to infinity, okay? I really don't care that it went to infinity. I care that it actually doesn't go to 0. That's what the test says. Even if your limit would not exist, that satisfies the condition of the sequence not going to 0. As long as that limit doesn't equal to 0, that's it. We can make our conclusion. And our conclusion is that therefore, by the divergence test, series 1 to infinity of n squared sine of 1 over n diverges. Okay, and that's it. Now this test works, as I said, it works really well when the limit doesn't equal 0, because you're done. Unfortunately, most sequences, when you take the limit of it, it's with a series, they're gonna go to 0, just the way it is. So it's not gonna, you won't use this test an awful lot, but when you do have the chance to use it, go ahead and try to do so. And more specifically, I tell people, why don't you just try to take a limit of your sequence, and if you're you're getting a hint that it's not going to go to 0, then maybe work with that limit and see what you get. But most of the time, it's going to be somewhat obvious that it's going to go to 0. Okay, thank you so much for your time.